Hi guys, this is lesson 8.2, multiplying and factoring. We are getting ready to do some of my favorite algebra stuff in the next couple of lessons, and that is mostly factoring. So we're going to ease into it with this lesson here. Just as a review, let's look at the vocabulary section. It says to place a check mark next to if a number is a multiple of 10 or an x if it's not a multiple of 10. So just a reminder, multiples are the numbers you get after multiplying. So like the multiples of 2 are 2, 4, 6, 8, 10, 12, and so on. The factors of 2 are 1 and 2. Those are the numbers that it can be evenly divided by. So pause the video and go ahead and place your check marks and X's where they should go. Okay, you should have something that looks like this. Basically, anything that ends with a 0 is a multiple of 10. Alright, so factor, the related words to factor are divide, factorable, factored form, and a factor is a whole number or variable that that divides another whole number with the numerator of, or with a remainder of 0. Basically, it just means, can you divide a number evenly by it? Okay, so for number 2, it says cross out the expression that does not have x to the third as a factor. So that means, which of these can we not divide evenly by x to the third power? And we can see that this one we can't, because that is x squared. Now, I'm trying to look at this on an iPad, so my screen is a little small, so I'm going to refer to my other screen on the computer to see what these other numbers are. Alright, x to the fifth can be divided by x to the third, because if we had x to the fifth divided by x to the third, we know that would be x to the 5 minus 3, which is x to the second power. So we know that x to the fifth can be evenly divided by x to the third. This term right here, it looks like x is only to the second power, but look at the x that comes after that. That means that we actually have x to the third power there. So it can be evenly divided by x to the third. Alright, and then the last one, once we distribute that 2 on the outside, we would have x to the fourth, which can also be evenly divided by x to the third. Alright, so problem 1 asks us what the simplest form of, right here, this problem 1 right here, what the simplest form of negative x to the third times 9x to the fourth minus 2x cubed plus 7 is. Basically, all it's asking us to do is multiply. So we're going to distribute here, here, and here. So this first one, we have a negative 1 here. So negative 1 times 9 is negative 9. And then x to the third times x to the fourth, we need to add our exponents. So that's just going to be x to the, not the 12th, I'm sorry, to the 7th. And then our negative 1 times our negative 2 gives us a positive 2. And then when we add the exponents on the x's, we get x to the 6th. And lastly, negative 1 times positive 7 will give us negative 7. And that will be x to the third power. Alright, pause the video and go ahead and work on your worksheet. Alright, for the got it one or the problem 1, you should have gotten 15n to the fourth minus 5n cubed plus 40n. And then over here in this section, this part might have been a little trickier for you. The greatest common factor between these numbers, we wanted to find the ones that had the greatest common factor of 4. And that was only this pair right here. It's tempting to think of this pair, but their greatest common factor is actually 8. And then the same goes on this row right here. On the next row, we needed one who's not 6. And it was tempting to think this one was 6, but actually it's 12. And then the same goes on this last row here. For problem 2, our book suggests that in order to find the greatest common factor, we should list the prime factors of each term. You are welcome to do it that way, but I find an easier way is just to consider the constants and then consider the variables. So if I look at the constants of 5, 25, and 45, I know the biggest number that they could all be divided by equally is 5. And then when I look at x cubed, x squared, and x, the biggest number that they can all be divided by is x. So that means when I put them together, the greatest common factor of these 3 terms is 5x. Pause the video and go ahead and try problem 2. Alright, you should have found that the greatest common factor is 3x. Now that we know how to find the greatest common factor, I'm going to show you how to factor it out. So if we have 4x to the 5th minus 24x to the 3rd plus 8x, I want to first think of what the greatest common factor is. And first I look at the constants, or the coefficients, of 4, 24, and 8. And I know the biggest number they have in common is 4. So I'm just going to write this right like this. And then when I look at x to the 5th, x to the 3rd, and x, the most I could take out of any of those is x. Okay, that's what we did on problem 2. Now problem 3, we go one step further, and we're going to show what this looks like factored. Basically, we're using the distributive property, but we're doing it backwards. So it's saying what times 4x will give us 4x to the 5th. Well, I don't need to multiply the 4 by anything at all to get 4. So what do I multiply x to the 1st by to get x to the 5th? And since when I multiply, I end up adding my exponents, that means I will multiply it by x to the 4th. Then I see that minus sign. I'm going to keep this minus sign here. And I think of what is 24 divided by 4? Or what do I multiply 4 by to get 24? And that is 6. And then to get from x to x cubed, I need 2 of them. And then to get on that next term, what do I multiply 4 by to get 8? Or what do I divide 8 by to get 4? And that is 2. And x doesn't get multiplied by anything to get x, so now I just close off my parentheses, and I'm done. And the way that I could check myself is to distribute, and after distributing, if I get the same thing I started with, I know that I'm correct. Just make sure that this is what you double underline, and not when you go check yourself. It's very tempting to go ahead and distribute and then call that your answer, even though it looks like the original problem. Alright, so pause the video and go ahead and try problem 3 on your worksheet. Since it has been a while since we have done prime factorization, I thought I would go ahead and work this out with you. To do prime factorization, you always start with the smallest prime number that something can be divided by. And that's usually 2. But since 9 is odd, 3 is the first, the smallest prime number that we can divide 9 by. And x would be the smallest amount of x that we could divide these x's by. I'm having a hard time. I'm going to increase my view on my other sheet so that way I could see what power that first x is to. Alright, it's a little difficult for me to see, but I think that first x is to the 6th. You can see on your paper. If I'm wrong, please forgive me and change your answers accordingly. But if that is x to the 6th, that means I still have a 3 left here and x to the 5th. And then this 3x can be divided by 3 and x, right? This one can be divided by 3x and, and x to the 4th. And then you can see they broke that 3 and the x down here. X to the 4th is x times x to the 3rd times x times x to the 2nd, and then x, and then x. And when you do it this way, then you just bring down your prime factors and put them all together. Honestly, what I would do is just what we did over here, and I would say the biggest thing that 9, 15, and 12, the biggest common factor they have is 3. And then I'm going to look at the x's, and I have x to the 5th or 6th, x to the 4th, and x squared, I believe. Again, this print is tiny for my 45-year-old eyes. And then I would just go ahead and double underline that. In the end, you should have gotten 3x squared times a quantity of 3x to the 4th plus 5x squared plus 4. I would really like to wait and do problem 4 in class. Feel free to read it and try it out, but I do want to discuss it together in person. Alright, go ahead and try the lesson check, and make sure if you have questions, write them down so you don't forget them, and we can make sure to go over them in class. See you soon.